Explain how negative 2 f of x minus 4 plus 12 is translated from f of x. If I look at the general form, I can see what each shift does individually. Now I'm going to record this by putting it and explaining it in this order. So let's begin by looking at the horizontal shift. And for that, I'm going to have to turn my attention to the h value. Here, my h value is equal to 4. And since I have a positive h value, I'm going to be moving to the right by this quantity. So moving to the right, uh, 4 units. And I can even emphasize that I'm moving horizontally. Now, if I want to know if I'm stretching or shrinking the function, I had to look at my a value. My a value is 2. Well, it's negative 2. So for the stretch and the shrink, let's just ignore the negative. So let's get the absolute value here. And the absolute value of negative 2 is just 2. And 2 is bigger than 1. If the number is bigger than 1, then we're going to have a stretch. If the value is in between 0 and 1, then we would have gotten a shrink. So here I'm going to say we're going to stretch the graph or the function. Let's put graph. Stretch the graph of the function by a scale factor of 2. Now, since my scale factor, my a value was negative, I know that that's going to cause a reflection across the x-axis. So my function, or the graph of the function, will be reflected across the x-axis. And then finally, to explain the vertical shift, I'm going to look at the k value. My k value is positive 12. So I'm going to go up or move vertically upwards by 12 units. And altogether, I'm going to be moving horizontally 4 units to the right. I'm going to stretch the graph of the function by a scale factor of 2. Then the graph of the function will be reflected across the x-axis. And finally, we're going to move vertically upwards by 12 units. And that's the explanation of how f of x got translated into negative 2 f of x minus 4 plus 12.